it's working. I think we're live. Hello world, it's Siraj. Okay, if we are live, that's great. Okay, we're live, great. Hold on a second. I want to show you this demo. And what you are seeing is essentially a demo of me using JavaScript to hack into my new Tesla. And in this live stream, I'm going to show you exactly how I did that. I'm going to show you how I use JavaScript to create a web app that can retrieve all of this data from my Tesla, and then we can even modify some data. And what we can modify is we can modify the climate. And we're going to use reinforcement learning from scratch, just pure JavaScript. This is so simple, guys. I want to show you how simple it is to hack into this computer car. Essentially, it's a computer with wheels. And in this live stream, I'm going to show you exactly how I did that. All the code is going to be in the video description, by the way. I'm just going to rewrite that code. But we're going to talk about reinforcement learning in detail. And 3 people from this live stream are each going to win $175 in Bitcoin by the end of the stream if they answer all 3 of my questions. I'm going to pick 3 of the people who answered all 3 questions correctly. All right, so I hope you're ready for this. Now, what are we going to talk about today? We're going to talk about autopilot. We're going to talk about autonomy in this Tesla vehicle. What does autonomy look like? Well, autonomy in terms of Tesla looks very different from other vehicles. It's something that you have to get used to, right? Like I wasn't really, even though I've been into deep learning for a while, it kind of was jarring to try autopilot for the first time. And in a few minutes, I'm going to show you a montage of me trying out all those autopilot features. It's a 3-minute montage. But the Tesla has a bunch of cameras on it. It's got 2 cameras on either side. It's got a camera on top. It's got a camera behind it. It's got a radar so it can detect proximity to other vehicles. And it's basically a computer. All of these sensors are connected as input-output devices to an onboard computer. And what else is connected to this computer? Everything. Every component in the car is driven by software from the ground up. From the air conditioning to the powertrain to the battery, everything is driven by software, which is why we love this car, right? Everything is driven by software as it should be. Now, that's the first part of Tesla, all of the components. What's the next part? Well, there's one component in particular that I really like, and that component is called the Full Self-Driving Computer, the FSD. And what you're seeing here is a diagram of the FSD. And of course, you're going to see some things that you'll find in all sorts of computers. You'll see a CPU for, single processes and, general, really basic process management. And then you'll see a GPU, and the GPU is for parallel processing. Now, what do we use GPUs for? Why would we need a parallel processor? We need it for deep learning, right? You know this. I hope you know this by now. We need it for deep learning. And now why does the Tesla use deep learning? It uses deep learning to see where it's at, to interpret the world around it, and to make the best actions to optimize its objective, which is to keep you alive and get you from point A to point B. And what you're seeing in this diagram is an NPU. You see 2 of these NPUs. And an NPU stands for a neural processing unit. It's a specific type of processor used specifically for the matrix operations that neural networks require. Now, why did they build a specific processor for this? Why didn't they just use a GPU like NVIDIA, or a CPU, or even a TPU like Google uses? Well, because Tesla has a very specialized AI. It does one thing really well, and that is to get you from point A to point B. And that means that a lot of the matrix operations that are going to be happening are going to be the same matrix operations in a row over and over and over again. In terms of convolutional networks, what do those matrix operations look like? They look like add, multiply, right? So there's like the same matrix operation, convolution, pooling, right? These same operations that are just repeated over and over and over and over again, given some input image or a frame of images in the form of a video, right? So that's why we have an NPU, because neural network processing is constantly happening on the Tesla. It is constantly using a neural network to perform inference and tell you where you are. And it needs to do this really fast because lives are at stake, right? Your life is at stake. You cannot mess this up. So the closer to the metal you make this processing happen, the faster it's going to be. So it's all about speed and efficiency. So, we could do all that neural processing on a CPU or a GPU or any number of levels, virtual levels above the metal. But the closer and closer we go to the metal in terms of running these matrix math operations, the faster it's going to be, which is why there's an NPU. Make sense? Let's keep going. So that's the NPU. And, overall, this system is essentially a multi-threaded operating system. It's an operating system, guys. Like I said, it's a computer with its own operating system. And what do operating systems have? They have process management, right? It is looking to see which processes are running, which processes should be killed, which processes are interacting, and it's trying to prevent any kind of thread mismanagement. Like, what did we talk about in our Rust live stream? We talked about the importance of thread safety. We talked about the importance of memory safety to make sure that threads know not to access the same memory location in order to prevent something like a deadlock, which is a system crash. We don't want that. So how good is Tesla's multi-threaded architecture? It's pretty good. It's not perfect. And I will show you how it's not perfect. One example that I found was I ran an Easter egg on the car, which was to play a simple song. It was called Ho 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 mode, like Santa mode. And then I tried to turn it off. It would not turn off, so that was not gracefully killing that process like I wanted to. And I tried to play another song and I didn't know which song to play. So again, thread safety and memory safety, very important. Is Tesla using Rust for this? No, they're using C++. How do I know this? I was just Googling it. They're using a bunch of C++. Of course they are. Andre Karpathy is the lead of Tesla AI, who wrote the original greatest AI blog post of all time, The Unreasonable Effectiveness of Recurrent Neural Networks. Go read that if you never have yet. That's the idea behind the Tesla computer. So now what are we going to do? I have my first question for you before we get started with Node. But before I ask you this first question, I have to show you what Autopilot looks like. So are you ready? Are you ready to see some Autopilot? I have this 3-minute montage that I made of me trying out all the different Autopilot features. What I want you to do is to watch this montage and pay attention, because right after it's done, I'm going to ask you the first question of this stream. And that first question is going to have to do with Autopilot. So I hope you're listening. Here we go. Enjoy. Autopilot montage in 3, 2, 1. Here we go. So this is basically the greatest car of all time. Like, without a doubt, I just love this car. I am in this car, sometimes just sitting in here, just chilling. You can even watch Netflix or something in this car, and it's awesome. Let's take a look at the Autopilot. So if we go to Autopilot, you can see that there's Auto Steer. So that's for city streets. Navigate on Autopilot is for highway on-ramp and highway off-ramp automatically. You can customize Navigate on Autopilot. As you see, I have it on Mad Max. Children, do not try this at home. Mad Max for speed-based lane changes. I guess I'm sort of an auto speed demon. But you'll see lane change notifications here. It requires lane change confirmations. I put yes to require. So if you put no, this is like, all right, so it's just going to automatically change lanes, and it's not even going to notify you. It's just going to do it. Are you sure you want to do that, you crazy person? And we're going to put yes. We put yes because we just want the full autonomy. Actually, that's a little too dangerous. So we're going to put yes, require. And so that's how that goes. That's Autopilot. You have Summon as well. Summon is amazing. And it just comes up to you. Lane departure avoidance is awesome. It just avoids the car departing lanes. And yeah, that's, oh, and then there's this Easter egg, of course. Romance mode. You ready for this? Yeah. Hold on. Yeah. Ho ho ho. It's Christmas. Autopilot engaged. Autopilot engaged. I am not even driving right now. My hands are not on the wheel right now. Autopilot is engaged. Nothing. My feet are not even on the wheel. Here are my feet. We're coming up to a stop. And my feet are, as you see up here, they're not even here. We are coming up to a stop. Nothing is on the wheel. It's totally autonomous. It's going up this bridge. It's going up at an incline. And there are cars coming at us. It's detecting everything with a convolutional network. It knows what the lanes, where the lanes are. It knows what cars are behind us, what cars are in front of us, what cars are to the side, the distance between cars. It's constantly computing these things with its amazing processors, onboard computing units. It's amazing. I love this car. Yeah. All right. So, what do we have here? I hope you liked that little montage. Now I've got the first question for you related to autopilot. So I hope you're ready for the first question. Let's administer this question live. The first question, let me pull it up here for you. Okay, we're going to go live in a second. Q&A. And begin accepting answers now. Okay, here we go with the first question. Which of these is not a component of Tesla's autopilot system? Is it A, the neural processing unit? Is it B, a convolutional neural network? Is it C, multi-threaded programming? Or is it D, K-means clustering? Now, all of these are related to machine learning, but one of them is not a component of Tesla's autopilot system. If you were paying attention to the montage, you know exactly what the answer is. And it looks like everybody knows. Most people have an exact idea about what the answer is. And so, while you guys answer that, let me answer some questions here. Pranav Desai has a question. What OS does it run on? Great question, Pranav. It's got to be Unix-based. It's definitely Unix-based for sure, because you can run shell commands so easily on this. I think it's a custom version of Unix. Related title says, I'm very grateful because it has allowed me to fund my project that I'm working on. I think that he might be referring to the prize money from last week. I think he won like $500. See, that's what I like to see, guys. I want to see you guys gain opportunities and employment and, all sorts of things from these games that we're playing. And that's absolutely what's going to happen with Code Royale when it's released. But I just can't wait for that to be released. So we're going to do it even before that. We're going to give out cash prizes and play games even before Code Royale is finished developing, because, someone once told me that if you have a job that you want to do, just start doing it before you even have it. Just like if you have a job that you envision yourself doing, just do it before you even have the job. And that's what these past 8-9 weeks have been. Let's now see what the answer is. It seems like almost every single person knows exactly what the answer is. All right, so I'm going to give you guys 5 more seconds. 5, 4, 3, 2, 1. All right, let's see what the answer was, guys. Finish and reveal. The answer was D, K means clustering. I hope you got that one right. That was the easy one for you guys. The next ones are going to be harder, so make sure to keep that in mind, all right? Now we're going to keep going. So the next thing we're going to do is we're going to actually build this thing in Node. So who's ready to build some hacks with Tesla in Node.js? I'm super excited for this. All right, so here we go with Node.js. We're going to create a custom web app that will log into this Tesla. And we're going to run reinforcement learning on this thing because I want to show you exactly how that works, why it's so important, and what all the utility is of reinforcement learning in this context. I want to show you a real use case of reinforcement learning, all right? Because it's a real technology. It's not just, for show. So what do I have in terms of a demo to show you here? In terms of a demo, I have an Ubuntu browser that will show you what the output is. So before I actually build it, I need to show you what the output is going to be. And in this case, the output is going to be the climate state of our vehicle. Let me just transition that. All right, so what you're seeing is the Ubuntu Terminal that shows the output of my web app. So let me just show you. So after a bunch of tries, after a bunch of errors and such, we logged in successfully. So what you're seeing here is me running that code that's in the video description that I hacked together. So what you're going to see here is, let me go up. Where was it? It was just working. So I got to show you that stack trace all the way up. Here we go. So what are you seeing here? What the car does is it first logs in. What the web app does, I should say. The web app first logs into the car just using OAuth 2. Just simple username, password, just like a server. Like I said, guys, this is a computer. Once you've logged into your car, it's going to notify you what its vehicle identification number is and its status, whether it's online or offline. Then you can make any number of API calls to see what its current charge level is. After you do that, you can make any number of API calls to see what the climate is. Is it on or off? That's a Boolean value. Then you can make an API call to see what the interior temperature is and the exterior temperature, so both. And then once you have pulled all that data from the vehicle, then you can run reinforcement learning. And that's what you're seeing here is that it's just like yo plus I'm printing out some random value from the training loop of a deep Q learning agent over and over again. So I've taken both of these two values, the interior and the exterior climate values. I've created a custom reinforcement learning environment in JavaScript. And I've told this agent to optimize this environment such that the interior of the car is exactly the same temperature as the exterior. Now, your first question might be, why would you do that? Why wouldn't you just manually set the interior to be equal to the exterior? And that's because we could do that, but this is more about a simple, the world's most simple reinforcement learning problem to show you how you could use this in your day-to-day life. Like I said, it's not perfect. It does work. It's not perfect though. Like, Tesla has a built-in climate system that's probably using AI, but we are essentially going to recreate that in JavaScript ourselves. Now, how are we going to even do that? Like, yes, we can, use Node.js. That's fine and dandy, but it's about more than just Node.js, right? It's also about the data, right? Any kind of AI starts with the data. So in this case, what does the data look like for Tesla? Like, what does the API look like? So what I'm going to do is I'm going to show you the Tesla API. Now, the Tesla API is never officially acknowledged by the company. Believe it or not, some dude made this. This website right here, Tesla does not own this website. It's all developers. So, so what are we going to do? This is the Tesla API. Every single Tesla vehicle has a set of API endpoints. You can log into your Tesla using the remote Tesla server. So it's kind of like a server client architecture, right? Overall, it's a distributed system. It's not decentralized. There is a master server that we could think of, and all cars are pulling data from that server. So if we can log into the server, we can log into our cars by the vehicle identification number. And once we're in the car, then we can see all of the API endpoints. And you might be thinking, wait, why hasn't Tesla ever acknowledged their API? I mean, if you look at all of the endpoints, like let's see state and settings for energy sites. What this is going to do is it's going to show us parameters and links for all of the Tesla API endpoints. This is going to give us live status site data. So if we go to owner-api.teslamotors.com/API/1/energy site /the site ID /live status, it's going to give us what some status is going to be, or historical data. It can give us all this data from the car, just insane amounts of data, which is crazy. Diagnostics, log data. I mean, there's so much here that we could pull from the car. Like I said, it's just a server. It's a computer. Our car has an API, and we could do anything we want with that API. So how are we going to access this API? Well, I found this amazing library called TeslaJS. And TeslaJS is the unofficial library to interact with the Tesla, and it basically wraps that API into a bunch of JavaScript functions. These are all asynchronous callbacks, and we're going to build that right now. But you can see a very, very simple example of it right here. So in this 10-line example, you require the library. You literally just set your username and password. This is how dead simple this is, guys. Like, you might be, I thought this would be a lot harder. Like, we got to hack into the firmware, and we got to, I was excited to do some serious hacking and like gain, admin access over the system. But nope, you can just literally log in with your username and password. And then you've got this callback, right? So this is an asynchronous callback. It's a design pattern used especially in Node.js to retrieve data when making a call asynchronously, which means, not sequentially, just simultaneously, using that username and password to retrieve an authentication token, just like any other OAuth 2 app. And then it's going to give us a notice like, hey, your login was successful. You logged in successfully. Good job. So let's try that. What do you say? Let's just try. This guy says it's super easy. So let's do that. Let's just copy and paste this 10-line snippet, make our own Node.js web app, and let's see if it's really that easy to log into our Tesla. So let me now open up Ubuntu, and we'll do that. So in Ubuntu, we'll go all the way down, and we'll open up, well, I already have it open up actually. It's called main.js. So I'm going to point us to main.js in the code editor, and then we're going to start coding in JavaScript. Who's ready to code in JavaScript? JavaScript is life. I love JavaScript, the language of the web. All right, we're going to start coding some JavaScript, and then I'm going to ask you question 2. So be prepared for question 2. It's about to start. So like we saw before, what did this guy do? He just imported his library. His library was called, what was it called? It was called, let me make this super big because JavaScript is meant to be read really big. We have var TeslaJS equals require, not esquire, require TeslaJS. That's it. We imported the library. Simple, right? What else do we need? Well, we need an HTTP library that's going to help us access the web, right? HTTP. What other library do we need? We need, that's it actually. Let's just start with that. Simple stuff. Okay, so we'll start with that. And then once we have that simple library, we will create our basic Node app. So Node has this design pattern where we have this is, the universal function in Node of creating a server. And a server takes a request and it's going to give us back a response. And after it's done that, the response is going to return something. What's the response going to look like? Well, the response is going to look like an HTML that it's going to, that's the start of it. It's going to start off as HTML. And the content type is going to be text, just plain old text. You know how it is. And after that, now we can log in with that. Let's paste that snippet in. Boom. Let me make this smaller so you guys can see everything. Bop, 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 bop. Okay. Is everything in there? Everything's in the screen? Yes. Okay. Look at that. So simple. Oh my God. Way too simple. Now, what is the email? I'll just put XXX, whatever for now. I'll switch this later. And then we'll get to question 2. Once this runs, we will get to question 2 because this is an example of connecting to the car. And once we've connected to the car, we are going to do something to the car. What else are we going to do once we're in the car? Let's not only connect to the car, let's also, once we've connected to the car, we're going to use that token, right? We're going to use the token that login was successful to run another callback. So this is called Callback Hell. This is one of the things that happens with Node.js. It's nothing new. There's a solution to Callback Hell. Callback Hell is when your code looks really fat. It's just a bunch of asynchronous callbacks that are nested one inside the other. Really easy to do for like a hacky prototype. You don't want to do that for anything in production. The way to prevent that is to use what's called promises in JavaScript. Promises help prevent Callback Hell and make your code more vertical so it's more readable. You don't want unreadable code, right? But that we don't care about that right now. We're just going to try to hack this together. So we have our token. We've logged in successfully. Now we'll use that token to get the vehicle, right? So we're going to use that token under options, using auth token as a parameter to get the vehicle VIN and the state of the vehicle. And we will see if this works now. So let's save that and open up Ubuntu, and we will see if that compiles and runs in Ubuntu. So that file was called main.js. So node main.js. It's like, no, we didn't expect that token on line 7, right? So on line 7, I want to make sure that related title's asking, why am I not using Express? Yeah, I could use Express, but because we are going to, I'll tell you why. Because we're going to import this reinforcement learning library that requires an import statement, which is ES6 syntax. And Express is one way to use that. Babel is the other way. We're going to use Babel instead of Express. We'll get to that. TeslaJS, HTTP. What am I missing here? Okay. Content type plain, 200. What am I? Oh, gotcha. Okay. I think I got it. Let me make sure that this is visible while I fix this code. All right. I really want to fix this code. Have you guys see what I'm doing here? What was it? It was like response.writeHead 200 content type text plain close. Okay, that should work. So now, if we compile that, you can see it's compiling. Node main.js. Good. But we need my username and password, which I'm not going to type in live. So some random person hacks into my car and makes it go all over the place. Don't do that. I will find you like Liam Neeson. You know that. I love that meme. Anyway. So that was an easy part. Let's get to question 2. We did something really, really, really basic here, which brings us to question 2. Let's bring up question 2, which is related to Node.js. So what is question 2? Question 2. I pull my face up and pull the question up as well. Question 2. Let me pull up question 2 for us. Question 2 is, okay. So what's the difference between machine learning and deep learning? I've had plenty of videos on both of these topics, but at this point, I kind of expect you to know the difference. Is it A, machine learning is a subset of deep learning? Is it B, deep learning is a subset of machine learning? Is it C, deep learning is not related to machine learning? Or is it D, deep learning is the same as machine learning? Those are your options. And while you answer those, I'm going to answer your questions. We've got some good amount of questions here. Here we go. Reclaimer117. Hey, John117 from Halo. I hope that's a reference. My favorite game of all time. Which architecture are these processors? Are they ARM-based mobile chipsets or x86? They're ARM-based. Well, some of them are. The CPU is ARM-based. I'm not sure what the NPU is. Yves asks, how do I manage time between school, very hard, and coding? So it's been a while since I've been in school, 10 years. And I don't miss it at all. Basically, I have my own school that I've created, which is my life. And I want the world to understand that it's possible to learn out in the open without some administrator or bureaucracy telling you how you can and cannot learn. Learning is not just restricted to the university environment or a school environment or any environment that other people tell you. Learning can happen while you're dancing. Learning can happen in a Tesla while you're driving. Learning can happen anywhere while you're having fun during this stream. So how do you manage that? You need to follow your curiosity. That's what I found. Like if you follow your curiosity, it'll feel like you'll be in your flow state and like 8 hours will pass during the day and you'll be like, wait, I thought it was daylight, and you just coded like a bunch. And that's what happens when you truly are curious about what you're coding. And you can't force that. You can't force that. So you really want to align what you're learning with what you're interested in and what you're curious about. E1LG asks, why is batch normalization so popular in computer vision? Because it's all about speed, right? Batch normalization helps, batch processing, first of all, is one technique to make training faster for these neural networks. And batch normalization is essentially, you're normalizing the data in batches so that it's all going to be on the same level playing field, that it's all going to be the same scalar values, all on the same scale. And if you want more accurate predictions, you want to normalize your data. That's like one of the key steps of data science. So that's why batch normalization is popular. Victor Campos says, is TeslaJS JavaScript package safe? Can I put the password there without a leak risk? Is the code open and secure? So I've been using it for a few days. Nobody's hacked into my car. Nobody would dare. No, I'm just kidding. Is it safe and secure? It's OAuth 2. It's the same protocol you would use for some... what popular site is using OAuth 2 right now? I think Facebook just switched to like something else, but almost every major site uses OAuth 2, so the answer is yes. As long as you keep your password secure, don't upload it to your GitHub. Make sure that your password is not in your code before you upload it, and then you'll be just fine. All right, so let's see what the answer was. Every single person knew the answer to this question except for one brave person who thought they knew that it was different. Let's see what the answer is. The answer is that deep learning is a subset of machine learning. You guys are making me proud by knowing the answer to that question. Good job, you get a sound effect. Congratulations for getting question 2 correct. And we're gonna move on to question 3, but we got some code to do, some reinforcement learning. So let's move this out of the way and get to the code. So back to the code. So we just built this simple TeslaJS web app. It connects to our car. It gets that climate data. It gets the vehicle identification number. Now we have that climate data. We want to do some reinforcement learning with it, right? How do we think about this problem, right? How do we think about a reinforcement learning problem? We have an agent, and an agent is going to perform an action in a simulated environment, and it's going to transition from one state to the next state depending on what its action is. When it performs its action, it's going to move on to the next state via what's called a transition probability matrix that defines the likelihood that it's going to move from one state to the next state. And when it moves from one state to another, it's going to get a reward. That reward will tell it whether or not it's successfully completing its objective. So let me just, before we start coding, let me just 30 seconds explain exactly the architecture of this reinforcement learning agent that I've set up. We connect to the car. We get all that data. We are retrieving just a bunch of data as a nicely formatted JSON file. In that JSON, we care about two values, interior climate and exterior climate of the car. We want those two values to be the exact same values. We could just manually switch the interior to the exterior, but that's no fun. We want to continually optimize the interior until it's the same as the exterior, because that will save us some energy, because we want to keep the car on as opposed to off and make sure that it's not too hot or too cold, but exactly that temperature. In order to optimize that, we're going to take both of these values, we're going to feed it to a reinforcement learning environment. So we'll create a custom environment. We'll create a neural network, and then that neural network will give it an objective. The objective of the neural network is to minimize the difference between the interior and the exterior. It will optimize that using calculus, backpropagation, and in this training loop, this is all happening in a simulated environment. This is all happening on my laptop, right? So we're just getting the data from the car as like a data stream every, X number of intervals. Let's say every 5 seconds, we're just getting that climate data. And then on the computer, we are optimizing this using a deep Q learning agent to make sure that any input and output data, the agent knows how to act. The action in this case is +1 temperature or -1 temperature. And the reward it's going to get is only if that difference is smaller than before, the last training loop. Does that make sense? So we want to continually minimize the difference between the interior and the exterior temperature using deep Q learning, which means we'll take a neural network, we'll try to learn the Q matrix, which is the matrix that tells us the value of every action, that every state that we could take given an action. And if you want to learn more about deep Q learning, literally, I promise you the best video on YouTube for this, I'm very confident about this, is my video. Just search deep Q Siraj. And there's this awesome video on it. You'll learn everything in 9 minutes. But that's the idea. So let's get to the code, and then we'll get to question 3. So question 3 is not yet. Here's the code. Here's the code. Here's the code. So there's our editor, and now we're going to look at the code. So where is the code at? The code is here. Okay, so what are we going to do with this code now? So now what we're going to do with this code is we're going to add some reinforcement learning to this code. So let's add some reinforcement learning to it. What are we going to do? There's so many libraries that we could use for reinforcement learning. Which one are we going to pick? If you go to NPM, which is the Node Package Manager, all I did was I searched reinforcement learning, and then I picked one. Reinforce.js was the most popular reinforcement library for JavaScript. And the reason I love NPM is because you don't have to do anything with like shell scripts and all these like little gluey things to get your dependencies to work. It's all packaged. That's the whole idea behind a package manager. It nicely packages everything you need into one command that you can run on your terminal, and then that's it. So assume we've run that, and now we're going to require that. So this is what related title asks why I wasn't using Express. This is why. So import, let me make this bigger. Import Dqn Solver, Dqn Opt, and Dqn environment. These are the 3 things that we need from the Reinforce.js library. We have the environment, the agent, and then the options, the parameters of that agent that we're going to define programmatically. So this is from the Reinforce.js library. Now, we can't just use an import statement normally with Node. That's why we need Babel, which we're going to install in a second. But that's the idea. That's how we import our reinforcement learning agent. Now, assume we have our reinforcement learning agent installed. Once we have that, we're going to create a custom function called reinforcement learning. We'll put everything in here. We'll put everything in this function. Reinforcement learning. We'll put the environment creation in here. We'll put the whole world in this function. We got the whole world in this function. We got the whole wide world in this function. Here we go. Function reinforcement learning. You ready? You ready? You ready? So we'll start with the width of the environment. We'll start with the height of the environment. These are really arbitrary values, but we'll just have 4 of these. We could have 1 million, but we're just gonna like randomly start with this. Like, this is the beauty of machine learning. We'll have to learn what the optimal parameters should be, but we're gonna start off with some simple ones. And now we can create our Dqn Solver. This is the agent, and the Dqn Solver is going to use an environment and a set of options. Now, what is the environment and set of options? We haven't defined those things. We'll have to define both of them. So let's do both. We'll define our environment. We'll say var env equals new Dqn env. These are preloaded functions. Now we can create all sorts of environments. You guys have some amazing questions. I can't wait to answer your questions in a second. Man, I love you guys. I love this. Don't you guys love this? I love doing this every week. It's so much fun. With height, number of states, number of actions. That's it. Number of states, number of actions. That's our environment. And we have our environment, and now we're going to create this option object, which is just new Dqn opt. And that's it. And then, guys, this is so simple. Like, seriously, I was so surprised at how simple it was to do this. And I say that because I want you to do something similar. I know not everybody has a Tesla, but, I like to think of this as our car. Yes, it's my car, but I think of it as our community's new car. And what I mean when I say that is that if you guys have any suggestions as to any kind of hack that I should do, a video with the Tesla, anything that you want me to do with it, let me know. And, we're going to take that into account, and I'd gladly do a video on that to make you guys happy and do something cool. All right. So those are our options. We have a var option for our Dqn options. Now, what is the one more thing remaining? We need the environment, which, oh no, we already have that. So that's end, that's opt. And then we have to, did we use, okay, we used all those things. So that's opt. So option, we could have any number of options here. All I'll do is one option, but you can see the original code that I wrote. There's like a million options, but in this case, we'll just have one. That's it. Okay. So that's a solver, and we're not done yet. I have like 10 more lines to code, and then I'm going to ask you the last question. We have our environment. We have our options. Let's build this training loop. So in JavaScript, we can create this learning loop manually as this function. And inside of the training loop, we will tell the solver to decide what the next best state is. So this is using a neural network. We didn't have to write out the network. It's internally using one. This is already built into the solver object that we instantiated earlier. And this was that yo part where I was like console.log yo plus the action that it decided to take. And you might be thinking, well, wait, where's state? Constant state is going to be an array of size, let's say 20 states. It's going to collect all the states over time. These are just single values, whatever that value is. And it's going to optimize that. So we have yo plus action. And so this is a single, all it's doing is it's just taking an action over and over and over and over and over again, depending on the state. And what we want to do is we want to make every action smarter. Now, how do we make every action smarter? Well, what we want to do is, to this reinforcement learning, we want to pass into like var interior climate and exterior climate. Let's call it interior and exterior, lowercase, because we don't care. Interior, exterior. So these are both climate values. And var last action, var reward. Now, here is like my hacky code right here. Here we go. I'm almost like kind of embarrassed to even share this, but guys, literally did this in like a day, and like, not a day, a few days. I'm not gonna, here we go. So where does this come in? We're gonna say if the action that was taken is, if there's an actual difference between those two values, then set the reward equal to the interior temperature. Now, why are we setting the reward equal to the interior temperature? Shouldn't the reward just be +1 or -1? Here's the truth, guys. I wanted a way to inject those temperatures into this like very, very much pre-built library, reinforced.js, and I didn't find an easy way to inject it into the environment. So I'm just injecting it in the form of a reward. So yes, this really is a reinforcement learning agent that really is using real climate data from the car. But is it using it in the optimal way that it should, in that these climate values are injected into the state directly? No. But could it in like a few days? Absolutely. But that's the idea. This is still like an example of a Markov decision process of states, actions, rewards over time being changed as we move forward with this. And I have one more line, and then we're going to get to the last one. The last line I have to write is Dqn Solver .learn reward. And that takes into the account the reward, and it modifies the neural network weight values behind the hood to be better and better and better, so that that reward is going to be, that interior temperature is going to be much closer and closer and closer to the exterior temperature over time. And we need to call that function as well. So we're going to call that reinforcement learning function inside of this loop. So inside of Callback Hell, we'll call the function using interior and exterior. Oh, we also need to get that. So I need to add another Callback Hell, and then we'll be good. So where's that climate Callback Hell? Climate, retrieve climate data. Where is it? Hold on. I'm going to get you guys this climate start. Give me a second. I've got this. Climate.js, and then we're done. Samples. Climate start. And then, there it is. Here we go. 3, 2, 1. Boom. Callback Hell. Okay. So what just happened? I just pasted in the climate start. It uses the same option. It tells us what the climate is. And then we'll give that the climate start. Yeah. It's going to return the climate. And actually, that's not the one I wanted. That was like a different Callback Hell. Here's the one I want. Yes. Perfect. Here we go. Boom. Climate fan status, inside temperature is going to be this. So that's what I'll say. Climate start, inside temperature, and outside temperature. There we go. Haha. Watch this give me a million errors in a second, but that's the basic idea. The code works. If you download this code, you run npm install all 5 of those dependencies, this code will run. Even if you don't have a Tesla, it will run. You just got to like create a Tesla account. And I wonder if it'll let you log in without a vehicle identification number. It will run, that's for sure. So that's that. Let me see what's next. I have a third question for you. Let me pull up the third question. Question 3 time. Here we go. I hope you're ready for question 3. I hope you were listening. We're about to do question 3. Here we go. Question 3 is, I hope this one's hard for you guys. Which process is used to frame almost every reinforcement learning problem? Is it A, Node.js? Is it B, policy gradients? Is it C, Markov decision process? Or is it D, process management? And, okay, good. This one seems to be a little harder for people. That's good. I'm going to make this harder, guys. You guys are getting too smart for me. I like that. This is good. I want you guys to be really good at these questions. Let me answer some questions, and then we're going to announce the winner, okay, in 3 minutes. Let me answer every single question here. So we've got 5 really great questions. Sankit asks, what's the next thing after machine learning gets saturated? Sankit, I give you my word that machine learning is not going to get saturated. It is going to continue to improve. And every time there's a blocker, maybe that there's not going to be an algorithmic advance, there will be some computing advance in terms of processing. There will be some data advance, some new data set is available. There will be some new educational advance. There's new people educating people on a new topic. It's not going to get saturated. This is the future. It's an exponential technologies. We want to focus on the exponential technologies of the future so we can exponentially bring forward a future that is more equitable and more beneficial for everybody in the world, right? Fully automated future. Will you do a video on image segmentation? That could be a good Tesla self-driving car video. I would absolutely consider that. Michael asks, why don't you use Swift for TensorFlow or Swift for machine learning? Because there are plenty of developers who talk about iOS-related technologies. I did help develop the first iOS app for Meetup.com a few years ago in New York City with Michael Gray. But we used Objective-C back then. Swift is way too easy. And also, You know what? Somebody said that I should do like a video on like deep learning on the M1 on the neural processor for Apple's new computer. That I will absolutely do, and in Swift as well. Arnav asks, I'm currently trying to make a simple ConvNet good, and I'm trying to use my AMD Radeon Pro GPU to enhance the speeds, but it's not working. Any solutions? Solution number one, sell your AMD, get the cheapest NVIDIA GPU you can find, install CUDA, and it will all be better. If you can't install CUDA, install the Docker image for it. Everything is, search NVIDIA Docker GPU, download, install, you'll be running in no time. 3 more questions. Anurag asks, hi Suraj, I'm 16 years old. Good. And my paper is being published in Scopus. Congratulations on deep learning. Thank you for teaching a bunch. It wasn't a question. Okay, you're welcome. Thank you, Anurag. Great to see that. Tiagarajan asks, Suraj, can you share your thoughts about Dqn? Dqn, great initial algorithm. It's what set DeepMind apart from the competition. It's what made DeepMind get bought out by Google for what was it, 500 million a few years ago. Great generalizable reinforcement learning algorithm. It's already been surpassed by AlphaFold 0 in every way. So not that great anymore. Still a great initial learning algorithm. Why does everyone think, they call me Ken, says, why does everyone think we'll get level 5 autonomy with cars? Because we will. We will get level 5 autonomy with cars. Go ask George Hotz. Go ask who I interviewed. Go search George Hotz Suraj for that interview. It's a super old interview. Go ask a bunch of other podcasters. It's going to happen. And go ask Elon Musk. Go ask Tesla. Like, this is their goal. Like, this Tesla will get literally smarter in like overnight with a software update. You can get hardware updates from over-the-air software. You can increase your acceleration from a software update, your torque, all that stuff. Incredible. Thank you, Yves, for the correction. One more question and then we're done. Is it possible, Katie asks, is it possible to extract the Tesla Autopilot neural network parameters after login and some hacking? That is what my initial thought was, KD. I haven't been able to do that easily. You're definitely not going to be able to do that from any Tesla API, that's for sure. That's going to require some kernel hacking. I would absolutely be down to do that in a future video. And that would be harder and that would make the questions harder. So that's a great idea. Let's see what the answer was. It seems like everybody knew the answer to this question. The answer to which process is used to frame almost every reinforcement learning problem is C, a Markov decision process. I hope you got that one correctly because now it's time to find out who the winner was and announce the winners, the 3 winners. We're going to announce all 3 winners right now. So here we go. The winners are, I'm now going to look up the winners. I'm going to let you know who the winners are right now. And then we are going to I'm going to sing a freestyle rap for the winners. So just got to pull up that live challenge. All right. I just got to find who just answered all that. All right. End session. View the results. Okay, here we go. I'm going to view the results now. Let's see who got this. Okay. Let's see. We have, the winners are Pranav Desai. Winner number 1, Pranav Desai. Congratulations, Pranav. Winner number 2, Ishan Dubey. So Pranav Desai and Ishan Dubey. Winner number 3. Let me just write their names out. Pranav Desai, Ishan Dubey. And winner number 3 is Gnuns. G-N-U-N-S like that. G-Nuns. Got all 3 of them correctly. G-N-U-Ns. Congratulations, Pranav Desai, Ishan Dubey, and Gnuns. All 3 of you win $175 in Bitcoin. In the next hour, email me hello@SirajRaval with your Bitcoin address and a screenshot of your win. If you don't have a Bitcoin address, that's fine. Just let me know. But email me within the next hour and I'll get that money to you within 24 hours. Congratulations, guys. So proud of you for winning that. If you didn't win, congrats, good job playing. I am now going to sing a freestyle for our winners. And it's a song plus a freestyle. And then we're going to talk about any closing things that we need to say, all right? So let's get that song started. Where's that music at? Where's the beat? Where's the beat? Where's the beat? Transition. Here we go. Music. Start playing. Yo. Shining, the nuns. Yo. One more time for my legends. I need a hero to plot my line. I need a hero to save inside. A hero to plot my line. I need a hero, bugs inside. Got my Tesla, got my autopilot, going left, right, back, and down. I'm excited, trying to rap and time it. I'm trying to time it, every single beat, line it up with every single line. The line of best fit is called regression. Are you dumb? Don't you understand? Every algorithm is used to find the secrets within the data. It's like a logarithm. It's like a exponential rocket ship to the future. Hero. Congratulations. That's what I like to see, guys. Each of you win. All three of you are my heroes. Thank you for playing this week, guys. It's been so much fun being here with you guys. I will be here the same time next week. You know what it is. If you haven't signed up for Code Royale, go watch that trailer. Sign up for the waitlist. Code Royale is the world's first educational esport. This is going to be the world's most valuable esport as well. I am now getting more confident every week with trying to communicate what it is that I've been working on and what I want to give to this community. I refuse to lose to apathy, and I refuse to lose the war to games that are not upskilling people. We have to retain the attention of the population of Earth by upgrading and innovating in education and turning machine learning into a game, a social multiplayer game. We're going to create legends. We're going to glorify these legends. These legends are going to win cash prizes, and they're going to have entire stadiums with fanboys and fangirls cheering after them. I have a vision. I'm not stopping until my last breath. I will see you here next week. 3 winners, $175 each. I love you guys. Last thing to say before this live stream, shout out to Zilliqa. Zilliqa helps sponsor this video. They're the reason that I'm able to give out $500 worth of prizes this live stream. Zilliqa is a blockchain run by Milan, Shukri, Arnav. These are great guys. They use sharding. It's a great blockchain. They're sponsoring this video. They're sponsoring the next video as well. But that's how that goes. Shout out to Zilliqa. Thank you, Zilliqa, for sponsoring this video. Zilliqa. If you haven't seen them, go check them out at the bottom of the video description. They've got some great links. Thank you guys for being here. I love you, and peace. Wherever you are in the world, good night, good morning.